Welcome to my presentation. In this presentation, let us look at some examples related to vector operations in 3 dimensions using the properties of vectors. Okay, let us say we have an example of this type. In this example, if A is a vector and if the components of these are 2i plus 2j minus k, and if B is another vector, and in here we have 6i minus 3j plus 2k, we want to find the dot product between vector A and vector B. So to do that, we're going to follow these following steps. Step number 1. The dot product between vector A and B, we can write this as 2i plus 2j minus k dot 6i minus 3j plus 2k, like that. And then as step number 2, we're going to state that I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1, and also I dot j is equal to 0, j dot I is equal to 0, and k dot I is equal to 0. So those are some of the basic properties of dot product. So therefore we will recognize those and we will implement them as we go expand these situations. So step number 3, we're going to then multiply them out. So 2i times 6i plus 2i times negative 3j plus 2i times 2k. Then we'll go to the second component of the first vector, which is 2j times 6i plus 2j times negative 3j plus 2j times 2k, and then the next element would be negative k times 6i plus negative k times negative 3j plus negative k times positive 2k. As we have seen here, that I dot j, this is going to go to 0, I dot k, that is going to go to 0, j dot I, this is going to go to 0, j dot k, this is going to go to 0, k dot I is going to go to 0, k dot j is going to go to 0, and therefore what is left here for us is as follows. 2 times 6 is 12, I dot I is 1, then 2 times negative 3 is negative 6, j dot j is equal to 1, and then negative 1 times positive 2 is going to be equal to negative 2, k dot k is equal to 1. Therefore, the dot product between vector A and vector B is going to be equal to 12 minus 6 is 6, 6 minus 2 is equal to 4. Therefore, the dot product is going to be equal to another scalar quantity. As we can, the one of the observations we see here is that when we have two vectors and when we dot product those two vectors, the scalar multiplication of those two vectors, the product is always going to be a scalar quantity. It is not going to be another vector. So that is one important observation we want to make. In my next presentation, we shall look at some more examples related to vector operations in 3 dimensions.